ke tlo explainer the velocity time graph ke shumisha this equation. This equation ke the equation of straight line. Re a tseba gore m ke gradient, so ke slope, and re a tseba gore if m is greater than 0, meaning if m is positive, re a tseba gore re ba le this shape ge re draw ya graph ya rena. And then if m is less than 0, meaning if m is negative, re ba le this shape. So re tlo relate this slope le the acceleration, our gravity. Remember that in vertical projectile motion always re na le the gravity ya 9.8, but e ka ba negative or e ka ba positive, it depends like the direction you choose. Let's say if we choose our upward is positive, this means downwards it's negative. And then re a tseba gore o ka kgona go choose gore upwards is negative and then downwards ya ba positive. So let's say if we choose gore upwards is positive, gravity re a tseba is always downwards, so gravity always is downwards. And then because now this gravity is in this direction, this means your gravity it will be negative. If we choose upward is negative, this means our gravity it will be positive, because now it's in the positive y direction. And then because ke gravity re relate le our slope, let's say if when I choose upward as positive, this means your gravity it will be negative. Therefore this means overlay this slope, because gravity it's only gradient. So re tsaba re na le gradient ya negative, this means re ba le this shape. And then let's say if upward is negative, this means your gravity will be positive because it's downwards. So this means it will be this shape, because this shape the gradient is positive, and then gradient is positive is in this way. So give the shape here the velocity time graph. Now let's interpret the velocity time graph. Are shumishe example gore gona interpret the velocity time graph. Let's say more than a building, and then this one is a ground, and then for object from this building, and then this object if it fast, the velocity at the highest point is always 0. The velocity at this point is 0 because this object fast it stop because something godimo gore se kgone go ya fase yo stopper e ya fase ge ka se stop e tla ya godimo forever and ever. So always the velocity at the highest point is 0. Let's say re choose upward as positive, re interpret this motion, and re tsaba gore if upwards is positive error fast ke negative. Now I level this motion, because this object it was not dropped ba latlela godimo era robale the initial velocity. Let's say if the initial velocity is 5 meters per second, and then let's say more get the level at the projection ya more object rena godimo. So this is this level, and it's important to understand the velocity at this point the initial velocity. This is the initial velocity, 5 meters per second. So velocity at this point, it will be 5 meters per second. But really upwards is positive. This means downwards it's negative. So that is why at this point, this velocity is negative. Or okay, in this way, this object in this direction, then here we are fast in this direction. So this means really the opposite direction. So that is why rebale the negative. But the velocity at this point on the ground. Another thing is important, the time it takes to reach the highest point from the point of projection. Let's say if each 2 seconds go fihla mo godimo, era gore e tlo tšea 2 seconds go fihla this level. The time it takes to go up, the time it takes to come down. Now, I'll share this information or draw the velocity time graph. And remember, upwards is positive. Gravity is always downwards. So because gravity is downwards, this means gravity is more than negative. So this means gravity is negative 9.8. And that's about gravity relate the slope. If slope gradient m less than 0, meaning negative, it about this shape. So because now gravity is negative, it for a velocity time graph expect this shape. Now I'll share this information on a velocity time graph. This is y-axis and then more x-axis. Always on your y-axis on your velocity in meters per second, and then on your x-axis on a time in seconds. So something always mo graph ya gago thoma gona your initial velocity. At level of this information, our initial velocity is 5 meters per second. So erelore are 5 meters per second here. More 5 meters per second. And then on the x-axis get time. Error expect a time on the x-axis. This object each 2 seconds of the highest point. So more valley 2 seconds. Always this point get the time it takes to reach the highest point. Always. So more than 2 seconds because this object is 2 seconds of godimo. And then moki get this level. Remember what this level near the initial velocity. So the initial velocity it was 5. So at this point the final velocity is negative 5 meters per second because of opposite direction. So at this point negative 5. Always this point get the level of the projection. So get this level. Roka first object godimo. So this level because di na le the same velocity, so ke this one. And then this object here e tsere 2 seconds o fihla mo. Remember, from here to here ke this one. And then from here to here ke this one. So this object go tloga mo fihla mo e tsere 2 seconds. Era mo roba le time ya 2 seconds, but re tlo ngwala 4 seconds because from 2 to 4 era re ke 2, so that is why mo re tlo ngwala 2 seconds. And then this object e feta this level e ya fatshe ya fihla on the ground, so era re yo feta that level ya -5. Let's say mo e fihla on the ground, so ha re tsebe re fihla ka velocity ya bokae, but let's just say e fihla ka velocity ya 20. But remember ke -20 because downwards ke negative, so mo re tlo ba le -20. And then let's say this object e fihlile mo fatshe ka time ya 20 seconds, so era re mo e tlo ba time ya this object ge fihla fatshe. So this information is very important. In summary, this point always y-intercept give the initial velocity, and then this point give the time it takes to reach the highest point, and then moki ge fihla from the same level ya mo a o lahlela object ya go godimo ka yona. And then this one ke that time ya go fihla ka yona on that level, this one. So e tsere 2 seconds, so era gore e tshwanetse be 2 seconds, so this one ke that velocity. And then this point ya mafelelo ke ge fihla the ground, so ye ke velocity ya yona, and then ye ke the time ge fihla on the ground. And then another thing ye is very important, gore o tsebe ro ka kgona go find the displacement. This object e tlogile moke ya fihla this height, so re ka kgona go kry-a this height re šomiša this graph. So ge re šomiša this graph re nyaka go kry-a this displacement from this point, or a is equals to half base times height. O ka kgona go bona gore actually mo re na le a triangle, because this is a triangle go ka lebelela. So ge re kry-a this displacement from the initial, a is equals to half base times height, and then our base ke this one, so error from here to here ke 2, so error mo over 2, and then this is height, error over 5, so error ka kgona go find this displacement. So ke the information ye gore e botlhokwa o tlo tshwanela gore o e tsebe. And then let's say if o choositše gore upwards is negative, and then your downwards e ra re tlo ba positive, and re a tseba re ge o na le upward as negative and downwards as positive, your gravity is always downwards, so e ra gore your gravity e tlo ba positive, and then e ra re o tlo ba le this shape ge o draw a graph. And therefore e ra gore wena o tlo ba le something like this one, o tlo ba le the same thing mara o tlo thoma di-points tša gago ka mo fase, and then o šomiša this same information. E ra gore ka mo initial velocity ya gago e tlo ba -5, and then this one yo ba ka godimo. This is because o tla bo change the direction, but o tlo kry-a the same thing. Let's say if re na le an object ye le gore is dropped, re a tseba gore if re na le an object that is dropped, this means re tlo ba le the initial velocity ya 0. Let's say re choose our upward is positive. If we choose upwards as positive, this means our downwards it's negative. And then because this object is dropped, this means here fast. Let's say if it mo fase ka final velocity ya 20, this means this final velocity you are negative because this object here in the negative direction. At level the velocity diagram ya this motion. Re a tseba gore on the y-axis always ke velocity, and re a tseba gore on the x-axis ke time in seconds. And remember re tšere upwards as positive. If re tšere upwards as positive, this means our downwards is negative, therefore our acceleration it will be negative because gravity is always downwards. So now e ka mo negative, this means re tlo ba le gravity ya negative. And re tseba re na le the gravity negative, this means re ba le this slope re draw a velocity time graph. Therefore re tlo ba le something like this one. This is the initial velocity as 0. And say let's say this object if it comes fast ka 20, this is going to be -20. Remember ka mo godimo ke positive, ka mo fase ke negative, o ya ka mo gore choose your direction ya rena. So this is -20. And then let's say if this object if it comes fast ka 10 seconds, so ke motion wa rena. And from this velocity time graph re ka kgona calculate the displacement, re ka kgona calculate this height. From the initial to this final, re tlo šomiša the area of triangle because o ka kgona lemoga gore this portion ke triangle, even this one ke ntho e tee. So re calculate area re šomiša this formula, and from here this e tla ba base ya gago, and then this one ya ba height. So from here to here e no tshwana le ge ke re is from here to here, so ke 20. So this means o tlo substitute ka 10 base ya gago, and then height wa substitute ka -20 because your object ya in the negative y direction, so re expect gore your displacement e be negative based on this direction. And remember gore if o choose upward as negative, this means your downwards is positive, and therefore your gravity it will be downwards, it will be in the positive y direction. Therefore re expecta gore o be le this shape ge o draw a velocity time graph ya gago. Therefore o tlo ba le something like this one. Remember this is your initial velocity, so o tlo ba le something like this one, and then mo ya ba the final velocity ge e betha the ground, and then mo ya ba time. A re lebelle the acceleration time graph. Re a tseba gore for a vertical projectile motion always re na le the gravity or the acceleration ya 9.8. So this value it can be negative or positive. E laola le ke the direction you choose for your motion. Let's say if we choose upward as positive, if we choose upward as positive, this means your downwards is negative, and acceleration is always downwards. This means your acceleration is over negative 9.8. Then how we draw the acceleration time graph? Something like, and remember on the y-axis on the acceleration in meters per square seconds, and then on your x-axis on the time in seconds. And relay upwards is positive, this means your downwards it's negative, and then because your acceleration is negative, so this means global negative 9.8 camouflage, and then you have your acceleration time graph. But let's say if we choose or up negative, if we choose up as negative, this means your downwards is positive, and our acceleration is always downwards, so this means your acceleration is in the positive direction. And then here we draw something like this. Global 9.8 here because keep positive. A great acceleration is always downwards, and then your acceleration in this case is positive, so global positive. So that's how we draw the acceleration time graph. A re lebelle the position time graph. Ke tlo shumisha this equation. Ke tlo shumisha this equation go explain this position time graph. Re a tseba gore this equation ke a quadratic, so ge re draw a parabola e ba in this form, and re a tseba gore if a is greater than 0, this means re ba le this shape, and then re a tseba gore if a is less than 0, this means re ba le this shape. So for our position time graph, a re bona as acceleration. If we choose upward as positive, this means your downwards is negative, and re a tseba gore acceleration is always downwards, this means your acceleration it will be in the negative y direction. So because acceleration it will be negative, this means we will choose this shape. This means how we draw your position time graph, we expect this shape. But let's say if we choose our upwards get negative, so this means your downwards is positive, and re a tseba gore acceleration is always downwards, this means now e ka mo the positive y direction, so this means your a is greater than 0, era gore o tlo ba le this shape, your position time graph. So always o tlo tshwana gore choose a direction ya gago, and then o tlo tseba gore shape e tlo ba in this way based on the direction. A re šomiše this example go interpreta the position time graph. Let's say mo re na le an object, and then o lahlela this object godimo, and then wa catcha gape this object at this same level. Let's say re choose upward as positive. Then ge re choose upward as positive, this means your downwards is negative. And re tseba gore acceleration is always downwards. This means your acceleration it will be negative because it's in the negative direction. And re tseba gore if acceleration is negative, e ra gore ge re draw ya graph ro ba le this shape. So a re lebelele gore draw ya bjang graph. On your y-axis, always on your position in meters, and then on your x-axis, on a time in seconds. So, ge o lahlela this object godimo, e ra gore initially position ya gona ke 0 because initially I need height. Remember, if something se sa le stationary before ya godimo, a gona ro ka ba le height. So e ra gore initially position ya rena ke 0. And then let's say if this object e fihla godimo, the maximum height from here, let's say ke 5. So this means o tlo ba le 5, and then here by your position time graph. And then this object, obvious, ge fihla on the maximum height, yo fihla ka a certain time. So let's say if fihla kwa godimo ka 10 seconds, so e ra re mo tlo ba le 10. And because this object e buile at the same level ya mo ge lahlela godimo ka yona, e ra la gore the time it takes to go up le kana le the time it takes to come down. This means if this object e tšere 10 seconds go ya godimo, e ra la lo ya fase e tlo tšea 10 seconds. And then re a tseba gore this time ke ge e fihla on the maximum height. So this means go ya fase e buya ka the same time. So mo re tlo ba le 20 seconds. The reason about 20 is because from 10 to 20 ra re edile 10. So from here to here ke 10. So ra re this time ya lekana 10 seconds ke ge e fihla on the maximum height, and then 10 seconds ke ge e fihla on the level yeo ge lahla godimo ka yona, this level. So ke ka mokgwa re draw yago the position time graph. And let's say if we choose upward as negative. If we choose upward as negative, this means your downwards is positive, and acceleration is always downwards. This means your acceleration is over positive. And then re tseba re na le the positive acceleration. This means re ba le this shape. Ge re draw our graph. So ge re draw this graph, or about something like re tlo dira the same thing, but the only difference in over the way o change how the values tša gago. So global something like this one, because ujere upward is negative, and then this means your downwards is positive. So error global something like this one. Now let's say if ranale an object yellow a building, and then this building is 20-meter high. O lahlela this object godimo, and then this object we are fast on the ground. And let's say if this object if it at the maximum height 5 meter high from this building, and then let's say if we choose upward as positive. If we choose upward as positive, this means our acceleration it will be negative, because downwards is negative and acceleration is always downwards. And ra tseba re na le negative acceleration e ra re ba le this shape ga re draw our position time graph. Now a re lebelele the position time graph. Re tlo thoma pele ra ngwala the height yellow object e mo go yona initially. So this object initially e mo height ya 20-meter high, so e ra ro thoma ka this height, and then this object ya fitla 5-meter high from the top of the building. Mo ke tlo ngwala 25. Mo ke 25 because from 20 to 25 ra re edile ka 5, so mo ke 20 and then mo ke 25. And then let's say if this object if fitla at the maximum height ka time ya 4 seconds, so this is the time it takes to reach the maximum height from this top of the building. And then let's say this object it's just 6 seconds of fitla fase on the ground from this position of fitla mo fase. Let's say it's just 6 seconds, so mo ke the time it takes to reach the ground. So if it's just 6 seconds, there are more globally 10 seconds, because from here to 4 seconds, so this means from here to here is 6 seconds, so that is why ever 10, because 4 plus 6 is 10. So ke ka mo draw the position time graph. O lebella the height yellow object mo yona initially, and then wa ngwala that height, and then wa lebelela gore this object if itla godimo ka height efeng, so yaba that height, and then this one get the time it takes to reach the maximum height, and then this one get the time it takes to reach the ground. But let's say if question area take the top of the building as the zero reference. So if question area take the top of the building as the zero reference, e rela gore o bona this building as a zero reference. So error global something like mo ke 5 meter, and then this object mo e tlo ba negative 20. Let's say if you're confused, we draw in this way. Here this top of the building, draw a Cartesian plane here. If this is Cartesian plane, and then ra tswa mo ke 0, so o ka kgona bona gore re na le this same thing ke this object re tšea this building as a zero reference, so robal something like this one. So re na le the same thing, and then because re rile upward is positive, this means downwards is negative. If this is Cartesian plane, error ka mo godimo ke positive, and then obvious ka mo fase ke negative, so that is why our displacement ever 20, this height ever negative. And let's say if re choose upward as negative, re choose upward as negative, this means our downwards is positive, and therefore our acceleration error it will be positive because it downwards. and then re globally this shape re draw our position time graph, then re global something like and then mo ngola di values tša gago go tshwana le the way re di ngwadilego. The only difference ko re tlo change di values tša gago based on the direction, and then for this one e ra re globally and then wa ngwala di values tša gago. So ke ka mokgwa re draw yago the position time graph. A re lebelele a position time graph ge le gore an object is dropped from the top of the building. So this building is 10-meter high, and then this object is fast. And then let's say if we choose upward as positive. If we choose upward as positive, this means our downwards it will be negative. And this means our global acceleration is negative. And then generally negative acceleration, this means we expect this shape. So here draw the position time graph, roll something like. And remember this object already is 10-meter high. So your trauma here. Because this object is dropped, roll something like. And let's say if this object if it on the ground 5 seconds, so more over time it takes to hit the ground. But let's say if question it take the top of the building as 0 reference, this means roll something like. And then more about the time, 5 seconds, and then here you have a -10. Remember, if your challenger draw the Cartesian plane on this building, and then more is 0, so probably the same thing. And because your upwards is positive, this means your downwards is negative. That is why our displacement is -10, because it comes fast, and then it comes fast negative because of the direction. And let's say if we choose up as negative, if we choose up as negative, this means our acceleration it will be positive, and then because it's positive, it will probably this shape. So how we draw this global something like. And then more about your time, and then more about the top of the building. So it's not difficult. I think this one it's straightforward.